welcome to the stage Mike Paquette.
All right, thanks, Kevin. Good morning, everyone. As Kevin said, my name is Mike Paquette, and I'm going to be talking to you today about the Elastic Common Schema for cyber threat hunting. This presentation is brought to you by the Elastic Security Analytics Solution. Happens to be an area within Elastic that I have the opportunity to focus all my time on, and it's one of the many use case solutions that you saw introduced this morning during the opening presentation. In fact, along the same lines, if you heard Dave Erickson this morning talk about how they observe a BLT using the food analogy, I think I had a little sweeter analogy here of what we're going to talk about today. Our agenda is quite simple. We're going to look at Elastic Common Schema. We're going to look, it's a good thing. It's a great experience by itself. We're going to talk about the capability to use the Elastic Stack for log-based threat hunting. We're going to put the two together with some examples, and we're going to see how they fit very nicely together to accomplish the mission. So let's start with the chocolate. How many people in here have heard about Elastic Common Schema? A good number, fantastic. The Elastic Common Schema is, quite frankly, would not have been possible without the help of many members of this community. It's something at Elastic we've been working on for a couple years, which is to come up with a common way to represent the data that lives in Elasticsearch documents, specifically the fields and field names that represent the various types of events that can be stored in Elasticsearch. And in this particular environment, we're talking about things like logs and metrics, but can also include application performance monitoring. Probably over a year ago, I had the opportunity to sit with some members of this community here and introduce this idea with some very basic concepts. And we had about 40 to 45 people that said, yes, this is something that you need to go do. And we've had just tremendous collaboration over the past couple of years to put this together. Just last month, we introduced Elastic Common Schema version 1.0, became generally available. And I can tell you that it's now being implemented in earnest because we've had more GitHub issues and pull requests on Elastic Common Schema in the last 2 weeks than we had for quite a while before that. So really, really thankful for the community to help us put this together. So at its core, it's just a specification. Elastic Common Schema is a spec, lists out the field names that can and should be used to enjoy a few benefits. And let's talk about some of those. The idea here, one of the benefits is that it enables the ability to do a normalized analysis of data from multiple data sources, even disparate data sources. And the idea behind it is actually quite straightforward. By normalizing that data during the ingestion process, you're able to take advantage of very, very efficient operations, searches, aggregations, visualizations on that data that previously would have required much more complex searches or may not have been possible at all. It does continue to be operated within GitHub as a public repository, yet the documentation for it is available live on elastic.co website. So you get the full documentation for Elastic Common Schema, and it's being kept up as part of any of the changes that evolve on GitHub itself. Very simple example, right? Before having a common schema, and many of you have had to implement your own common schemas because this problem is actually quite apparent. But if you had, let's say I was a security analyst or operator of a SOC, and I had firewalls that I'd like to visualize within Kibana. So a few years ago, I went ahead and built out a dashboard for my Cisco ASA firewalls. It was very productive. It gave me a good visualization overview of what was going on, perhaps in terms of traffic that was allowed or blocked, or even the geographical distributions of where that traffic may have been initiated or where my users are reaching out from. All was good until one of my groups within the organization deployed a different type of firewall, maybe in the Palo Alto firewalls, and I wanted to use that same dashboard on it, but I realized that the events that were coming from the Palo Alto had a lot of the same information, but it was represented in entirely different fields with different field names. So I couldn't use my dashboard, and I didn't really know how to solve this problem. So I went and built out a second dashboard to give me the visualization and the access to the information coming from my Palo Altos. And then I discovered we had a whole additional group that was putting their firewall information into their existing security information and event management system from ArcSight, and I had to integrate that into my Elastic Stack as well, and that had yet a different representation. So I ended up, if I wasn't careful, with 3 different dashboards just to get a view into what was going on within my firewalls. By adopting a normalized schema, specifically an elastic common schema, the idea is I'm able to consolidate that information by using a common normalized set of field names to have a single set of visualizations and dashboards and alerts and reports for my firewalls. And I don't lose anything. Of course, I can still use the filtering capability of Kibana to filter down if I wanted to see one particular class or event type of firewalls. So this is just a very simple example. To many of you, this is obvious, but this is the primary motivation behind the introduction of the elastic common schema. So first of all, I'd like to point out that the elastic common schema is an inclusive specification, which means it doesn't say you can't have anything but these fields. Instead, what it says is these are the common fields within elastic common schema. If you populate those and use those regularly, good things will happen to you as far as your ability to analyze and visualize data. But if you've got additional fields, no problem. As long as they don't collide with the basic namespace objects that are already in elastic common schema, you're free to use those. And this inclusiveness is actually going to help in a couple ways. It helps during migration of data from non-ECS to ECS, and it also helps in handling things that weren't yet accommodated by elastic common schema. We set out with a very broad set of goals in terms of the types of data sources we'd like to accommodate, but as we've been learning recently, the more it gets used in earnest, we're finding additional things that will be added. So we think the specification will be evolving over time. We are implementing it with semantic versioning, which means there will be every effort extended to not have any breaking changes, that is to change the way that existing defined fields are used, but it will gladly accommodate new fields to be able to more carefully and more completely represent data from different sources. So if it's not an elastic ECS core field, which are the basic fields that all types of events should attempt to populate, if it's not an ECS extended field, which is a more extended set that might be use case specific, like for security analytics, we'll have field sets for threats and vulnerabilities and things that aren't necessarily relevant to other use cases. If it's not one of those two, it's a custom field, no problem. Make sure it doesn't collide. The fields can coexist. So the benefits, if they're not obvious, let's just run through them quickly, right? One, the first biggest benefit is that you're able to easily correlate data from different sources. In fact, what you find out with Elasticsearch, the ability to search across multiple indices on a given set of field names, and we'll talk later in the threat hunting side on how you can even more specifically do this, but the point is even searching becomes implicit correlation. Number two, it gives you the improved ability to remember the field names. This is actually a real problem in environments that don't have a normalized schema. There's so many variations of field names to represent a single logical entity that this becomes problematic for the actual analyst doing the work, and they're constantly opening up other windows to refer to learn the field names. A single set, modest number of field set names coupled with, if you don't remember them, there's a set of field naming guidelines that are predictable. So if you don't remember the name, you can probably deduce it. Right? So these are real practical advantages to the analyst. And perhaps some of the bigger advantages are that the content that you deliver, by content, I'm talking about saved searches, visualizations, dashboards, reports, machine learning jobs, and alerts. All that content that is dependent on the representation of the data in the Elasticsearch indices, this now gets to be reusable. If you build that content based on the elastic common schema field names, it now just works across multiple data sources. So what can you do? You can share that content with different groups within your organization. If you choose to and have the opportunity to, you can share that with the community. And in the case of Elastic, if you're using Elastic apps, as Elastic apps embrace the elastic common schema, you'll be able to use those apps on your data because you've already got it represented in ECS format. So there really are a lot of advantages to this, and these are the underpinnings and the motivation for putting together the elastic common schema. It's not massive. I mean, there are a couple hundred fields that are in there, but they're organized into 25 field sets. And if you have a chance to look at these, it's actually quite logical. In fact, I'll show you just a couple examples in just a moment. Don't worry about all the details on this slide. There's one point that's here. So when we set out to build Elastic Common Schema, we realized we developed this in the English language, and we realized there wasn't enough words to be able to give a one-word definition that would mean the same thing to every one of us in the room about what we were talking about. Things like systems and hosts and devices, you'd think that those are very self-explanatory. No way. Every discussion we had on GitHub, if there was 5 people involved in the discussion, we had 6 opinions on what each of these things could mean. So what we had to do was, this wasn't just a specification, we had to develop a real data model and to think about how the different field sets would be used. And in this very busy slide here, but the idea is very simple, right? We defined the host as the computing instance where the thing that happened, the event, took place. And if that happened to be inside of a cloud environment, then we had a set of fields that described the cloud environment in which that host was running. And if we had an agent that was running on the host, maybe it was an Elastic Beat or a syslog agent, then we had a set of agent fields that described the characteristics of the agent. And so we put together 30 or 40 of these common and not so common use cases to try to build out the data model that would ensure, or at least increase the probability that the field sets we had would accommodate a wide variety of events. And it turns out we did a pretty good job, but we're finding new things that we didn't think about. Here's the most important point. If you look way over on the right in that tiny little chart, of those 25 field sets within the Elastic Common Schema, you don't have to fill every one out for every event that you have. You fill out just the ones that are relevant to the data that's coming in. So if you can imagine in that table on the right that each of the columns on the left represents one of those 25 field sets, you'll see that for a given event, only a subset of those is populated. So this is really a pretty straightforward process if you're attempting to transform or migrate your data into the Elastic Common Schema. Speaking of transforming or migrating data into Elastic Common Schema, so you've got events today within your security infrastructure. They're coming from your firewalls like we looked at before, your web proxies, your endpoint detection and response tools. They might be coming from Elastic Beats. And your goal, if you believe in the benefits of Elastic Common Schema, is to try to get each of those events transformed into this ECS format as they're being, or before they're indexed into the Elastic search indices. And so there's kind of 3 logical places that this transformation could happen, right? 1, it could be done by the data shipper itself. So if you've got an agent or a forwarder or a beat, that particular entity could do this transformation as it's pulling the data from its native source. Makes sense. And in fact, in Elastic Beats, as of version 7 this week, all Elastic Beats will be populating Elastic Common Schema fields, which is a great thing because you'll be able to get a head start on this if you're actually using Elastic Beats. The other place that this transformation could be done is during the extract, transform, and load process. This could be Logstash, or if you're using additional tools to migrate your data and transform your data before it gets ingested into Elasticsearch, then of course you can do the transformation there. If you're using Logstash, you can use either, you could build new grok patterns, or perhaps more flexibly, you could build a mutate function that does essentially either copies to or renames the existing fields that you have onto the corresponding ECS fields. Work to be done, but actually pretty straightforward. The last place that this could also be done is during the processing of the ingest node pipelines within Elasticsearch itself. The ingest node pipeline is being rapidly innovated to have more and more capabilities to perform transforms like this just before the data is ingested into Elasticsearch indices. So there's a lot of areas in which this transformation would be done. Now this is not trivial, but it's actually not so bad. So migrating your data from the existing state that it's in today into Elastic Common Schema format basically can be done a couple different ways. Because ECS is an inclusive specification, one of the things that you can do is you can use the temporarily overstuffed event technique, which is to keep all your own fields and also include the ECS fields. Not very efficient from a storage point of view, but completely protective of both old analysis content and new analysis content, new data and old data. Okay? That could be used as a temporary measure, and as the old data ages out, you simply stop using the old content, migrate everything over to ECS, not as easy as I just said that, but then you're done. But there's a more intelligent and perhaps a more concise way to do that, which is by using Elasticsearch field indices. If you have existing analysis content, all those things I talked about as content, and you'd like to be able to operate that on new ECS data, one of the things that can be done and is being done in the beats in 7.0 is by specifying a set of field aliases for all of the old field names that you may have been using to map them onto the current ECS fields. And by putting those field aliases in place, it means that your existing content will work on new ECS data. Okay? So there's a couple ways to approach this. We're going to be introducing, we've had one introduction to ECS blog that we've already published. There'll probably be 3 more that will give concrete examples for beats, other data sources, and some of our observability solutions to be able to do those migrations. So anyways, pretty exciting stuff. When we move from the chocolate to the peanut butter, we're going to talk about threat hunting. And some of you have seen, we've talked about the usage of the Elastic Stack as a very, very efficient tool to enable analysts and hunters to be able to do threat hunting through, and I'll be precise, through log data. Right? There's many disciplines within threat hunting that move the hunt from the logs into the memory of existing running systems. We're going to talk about log-based threat hunting in this particular space. Like a lot of things we do at Elastic, and like you heard this morning from Dave and Shai, is that we see threat hunting a lot like a search problem, and that's probably not surprising that we're here at Elastic. But the difference here with threat hunting, log-based threat hunting, is that of course it's a proactive retrospective measure. It works on the presumption that the that the adversary has actually already infiltrated my network. I'm going to go look at things and be able to presume that that's the case, go try to find them. So if, according to some sources, threat hunting is pretty high up on the hierarchy of cyber defense needs. If you're familiar with the Swanman incident response hierarchy of needs, you'll know that the idea is if you've implemented threat hunting successfully, your organization will have the capabilities that in the event of a red team exercise would be able to basically detect the intrusion activity of the adversary and follow along with it at multiple points along the kill chain. This is all really good, but in terms of methodologies that you use, there's many different approaches. I really like this one synopsis of they fall into 3 basic categories of threat hunting. We're talking about the analytics-driven, where we're using some type of analysis on the data in advance to give us a starting point for the hypothesis that we're going to use for our threat hunting. Situational awareness-driven is much more conventional in the sense that you're identifying the crown jewels of your organization and then focusing your hypotheses around that particular logical or physical set of infrastructure. And then lastly would be intelligence-driven, looking at threat information, both publicly available and internally generated threat intelligence to try to use that as the starting point for building hypotheses to begin your threat hunting exercises. If going back to the pyramid, one of the things that we'll find is that it turns out that both those things are fall under the category of threat hunting, but if you've got threat information and intelligence, that would support the intelligence-driven hunt, and if you've got behaviors, that would influence and provide the ability to do the analytics-driven hunting. We're going to take a look at the analytics-driven hunting as an example here. So in cyber, behaviors are typically things that are known as tactics and techniques, or TTPs. And by the way, jumping back to Elastic Common Schema for a moment, one of the areas that's currently being integrated into the Elastic Stack, there's a pull request for it, is to have the appropriate place to do direct mappings from frameworks like the MITRE ATT&CK frameworks, tactics and techniques into ECS. So this is actively being developed as we speak. But what we've got here is looking at tactics and techniques. What we're going to see in just a moment, we're going to go see a model that represents the way threat hunting could work, and certainly picking a tactic first and then beginning to build your hypothesis is what it's all about. Excuse me, could I have the notes go back just one slide, please? Great. Thank you. A really great blog by Jen Bielski from expel.io proposes this threat hunting process that's shown here. And I really like this because, first of all, the feedback loop shows the iterative nature of threat hunting, certainly log-based threat hunting. And the idea here is you pick an attacker tactic. You might choose to adopt the MITRE ATT&CK framework. You might have your own set. You determine a hypothesis. I think that if an adversary was to gain credentials access to one of the privileged users in my environment, they might try to log in at a time unusual for that user. That's a hypothesis. It might be a good one, it might be a bad one, but I start with a hypothesis like that. Next, I have to gather the data that would enable me to test whether that is a valid hypothesis or not. And by the way, this is the hard part, right? In fact, you really have to have this data collected earlier. And this is really where the Elastic Stack itself is such an enabler for threat hunting, because if I've got the data, the ability to do ad hoc searches without knowing in advance what I might have wanted to look at using Elasticsearch is what makes it such a good platform for this type of log-based threat hunting. But in the case of this example, I've got to make sure I actually have the data, and it has to be readily accessible. Guess what? Elastic Common Schema works wonderfully here, because if I have the data, I'm going to know how to search for it really easily, because it's going to use a set of common field names to represent that data that I might want to go look for. Once I've identified that data, I'm going to filter it to try to make sure, try to basically understand, to do my investigation, determine whether or not my hypothesis is valid. And then lastly, I'm going to review my results, document it, and a lot of times, my hypothesis was not good. Document those anyways, park it on the side, set a 6-month reminder to come back and look again, because in 6 months you may have more data and the world may have changed. So this is the general process. And one of the things that we do see is that we cheat a little bit. A lot of times in the Elastic environment, if you know you don't have the data source necessary, then don't start down the path. Look first, take an inventory of what data you have, and try to do some matching of the tactics and techniques that you're looking for with the data set you have available. And again, ECS is going to be wonderfully efficient and helpful here to help you identify which data that you do have available so that you can make those smart decisions when you're starting the hunt. So a couple things. Let's take a look at a couple examples. And again, this hopefully is where the peanut butter and the chocolate come together. I think the kids have been bugging me about Easter baskets, so I got Reese's peanut butter cups on the brain here. First of all, one set of field names. Again, this is going to be really, really key when you have to find it. You set out with a hypothesis at a high level of what you want to get accomplished, but you don't necessarily remember all the field names. If you're online and you have access to the website, elastic.co has a complete field reference for all the ECS fields, including their nested combinations where they can exist. If you have to work in an air-gapped environment, there's plenty of files available in the ECS repo. You can safely and securely find a way to get those into the air-gapped environment and then use that as an offline reference. We've even got some cool Canvas work pads that allow you to build a ECS field selector based on a CSV output that is generated as part of the Elastic Common Schema repo. So this is going to help kind of generally across the board, both in ad hoc searching and in threat hunting. But a couple interesting ones here, and sorry for the hand-drawn scribbles here, but leading wildcard searches is actually very powerful when you have a regular naming structure underneath that you can count on, like Elastic Common Schema. So in this particular scenario, sorry for the smallness of this, but you'll see that within, this is the Kibana Discover window, and I've got the index pattern of just a star, which means I'm looking across multiple indices. In this case, in this experiment, I've got audit beat, packet beat, file beat with a number of different modules, all populating data from a variety of sources around the infrastructure into their own respective indices, but I'm looking across them just at one time. And in the top center, you see there's a star.ip : and then an IP address. This will locate for me the presence of that IP address in any of the fields where it may be used, in any of those IP address fields, which is actually really, really powerful when I want to find out, hey, show me anything that's been going on with this particular entity. That's with an IP address. Same thing holds true with host names. So there are multiple logical entities. Remember the data model that we talked about within Elastic Common Schema? Well, it turns out that the .host name is applicable to hosts, of course, but also what about other entities? Like what is a firewall in Elastic Common Schema? Well, the logical construct in the ECS data model is that it's an observer. An observer is a device that sits out on the network and or elsewhere and that is making observations about things that take place over the network or on a host. Observers have their host names too. So what if you like to look at these? These types of leading wildcard searches can be very powerful. Now, of course, you can just, if you have your data indexed properly, you can just do full text searches across everything, but you'll find that these searches are very targeted, very precise, and very comprehensive in terms of giving you what it is you may be looking for during the hunt itself. So another one we could look at is event categorization. One key to any data model is having the ability to have a canonical set of categories into which multiple types of events can be and are classified. So there are a number of event fields in Elastic Common Schema. Although it's all about events, there is a field set called events and has a number of categorization fields in there. This work is not complete. This work is still ongoing. But the implementation so far, for example, there's an event.kind that lets me know whether or not my events happen to be, quote, events coming from various sources, or they could be alerts that might be generated by an intrusion detection system, or they could be alarms that were generated by SIM-generated tools like correlation rules, machine learning jobs, things like retrospective threat matching jobs. Could be an alarm. In this regular format within ECS allows me to do very easily things like visualizing the overall status I have in my Security Operations Center. I think we might get a glimpse a little bit later today of how that might look in a Canvas workpad, for example. But this is all enabled by Elastic Common Schema. Event actions, right? Open file, user login, process executed, process started. All these types of values that are being specified as enumerated values in Elastic Common Schema will allow you to really understand through search, through threat hunting, what is going on the systems. And hypothetically, if Elastic were to introduce new apps that took advantage of this information, you would find that as long as your data was in ECS format, you'd be able to use your data during the hunting process to understand these types of actions. And of course, event outcomes is one of the capabilities as well. So you want to know whether I log in events. Do I want to look at the failed ones or the successful ones or both? So this event categorization is something that is super, super enabling in terms of performing threat hunting. So to kind of wrap it up here, what we're talking about is Elastic Common Schema. It's available as a specification now in version 7.0 of the Elastic Stack. All the beats will be populating Elastic Common Schema fields. The beats modules will have extensive details populating even the extended fields, but all the beats will have the basic capabilities put in so you'll be able to use that data. In terms of the future, I think what you'll be seeing is Elastic apps taking advantage of that and being able to perform their work on ECS formatted data. That's it. I think we're ready to move on. Thank you, everybody.